We may recall that a circle is the set of points in the plane equidistant to a fixed point. We have seen several examples of circles in the previous videos wherein we sketched their graphs and determined their equations. In this lesson, we will focus on a particular circle and its properties. We will call it the unit circle. We start with a definition of the unit circle. Unit circle is a circle whose center is at the origin and with a radius of 1 unit. Its equation is given by x squared plus y squared equals 1. If point P is moving on the unit circle and starts at 1, 0 and terminates at x, y, the point generates an arc. This arc corresponds to a central angle theta in standard position. Theta is positive real number if the arc is drawn counterclockwise from point 1, 0, and negative if the arc is drawn clockwise from 1, 0. Point 1, 0 is the starting point in the unit circle. From this, we can define two separate functions. First, we have function of cosine theta to x, which is the abscissa of point x, y. That means cosine theta is equal to x. Second, we have function of sine theta to y, the ordinate of point x, y. So sine theta is equal to y. We can also define the other trigonometric functions of theta. Remember SOHCAHTOA. TOA. Tangent theta is equal to y over x, opposite side over the adjacent side, where x should not be equal to 0. Cotangent theta is equal to x over y, reciprocal of tangent, and y should not be equal to 0. Secant theta is 1 over x, reciprocal of cosine, and x should not be equal to 0. And cosecant theta is equal to 1 over y, reciprocal of sine, and y should not be equal to 0. These 6 functions are defined as the circular functions: cosine, sine, tangent, cotangent, secant, and cosecant. What is a circular function? Circular functions are defined in terms of the coordinates of trigonometric points on the unit circle. Real numbers such as pi, pi over 2, pi over 3, pi over 4, pi over 6, or any value of theta is associated with ordered pairs, x, y. Using the definitions of the 6 circular functions, we can determine the values of the circular functions of its multiples. In the unit circle, this is the starting point. So this is 0 degree and it has coordinates 1, 0. This point is 90 degree or pi over 2 in radian with coordinates 0, 1. While this point is 180 degree or pi in radian measure with coordinates -1, 0. On the other hand, this point corresponds to 270 degree or 3 pi over 2 in radian with coordinates 0, -1. And finally, this point also corresponds to 360 degree or 2 pi in radian measure. It has the same coordinates with 0 degree. Using the definitions of the 6 circular functions, which are the following, we can determine the value of each of the following angles. We start with 0 degree. Define the 6 circular functions when theta is equal to 0. On the unit circle, 0 degree has coordinates 1, 0, where x is 1 and y is 0. Thus, cosine 0 is 1. Cosine is equivalent to x, and the x value here is 1. That's why cosine 0 is equal to 1. While sine 0 is equal to 0, sine is equal to y. How about tangent 0 degree? Tangent is equal to y over x. Since y is equal to 0 and x is 1, 0 divided 1 is 0. Thus, tangent 0 degree is 0. While cotangent is equal to x over y, that is 1 over 0, and this is undefined. So cotangent 0 is undefined. Secant 0 is 1. It is 1 over x, where x is equal to 1. So 1 divided 1 is 1. while cosecant 0 is undefined. Cosecant is equal to 1 over y, where y is equal to 0, so 1 over 0 is undefined. So these are the 6 circular functions of 0 degree. How about when theta is equal to pi over 2 or 90 degrees? Pi over 2 or 90 degrees has coordinates 0, 1, where x is 0 while y is 1. We follow the definition of the 6 circular functions. We have cosine pi over 2 is equal to 0, the x coordinate. Sine pi over 2 is equal to 1, the y coordinate. Tangent pi over 2 is undefined, y over x or 1 over 0, and that is undefined. Cotangent pi over 2 is equal to 0, x over y or 0 over 1, which is equal to 0. Secant pi over 2 is undefined. 1 over x, x is equal to 0, and 1 over x is undefined. And cosecant pi over 2 is equal to 1. 1 over y or 1 over 1. Y is equal to 1. 1 divided 1 is 1. So these are the 6 circular functions of theta pi over 2 or 90 degree. Next, let us determine the 6 circular functions of pi or 180 degrees. Pi or 180 degrees has coordinates -1, 0. X is -1 while y is 0. Thus, cosine pi is equal to -1, the x value. Sine pi is equal to 0, the y value. Tangent pi is equal to 0, y over x or 0 over -1, and that is equal to 0. Cotangent pi is undefined, x over y or -1 over 0, and that is undefined. Secant pi is equal to -1, 1 over x or 1 over -1, which is equal to -1. And cosecant pi is undefined, 1 over y, where y is equal to 0. And these are the 6 circular functions of pi or 180 degree. Let us also define the 6 circular functions of 3 pi over 2 or 270 degrees with coordinates 0, -1, where x is 0 and y is -1. We have cosine 3 pi over 2 is equal to 0. Sine 3 pi over 2 is equal to -1. Tangent 3 pi over 2, which is undefined, y over x or -1 over 0, which is undefined. Cotangent 3 pi over 2 is equal to 0, x over y or 0 over -1, which is equal to 0. Secant 3 pi over 2 is undefined, 1 over x and x is equal to 0, so it is undefined. While cosecant 3 pi over 2 is equal to -1, 1 over y or 1 over -1, which is -1. And we now have the 6 circular functions of 3 pi over 2 or 270 degrees. And finally, let us also define the 6 circular functions of 360 degrees or 2 pi. But take note that 0 degree and 360 degrees have the same coordinates, which are 1 and 0. Therefore, we just copy the 6 circular functions of 0 degree. So these are the 6 circular functions of these theta angles. Even without using calculator, you can determine the value of these angles on the unit circle. Moreover, we can also determine the value of an angle which is a multiple of pi over 2 or pi. This portion is equivalent to 1 pi over 2 or 90 degrees. If we take another portion, we now have 2 pi over 2. Dalawang pi over 2 or dalawang tig 90 degrees. 2 pi over 2 is equivalent to pi. That's why we have here pi. If we shade another one, we now have 3 pi over 2, which is this value here. And another one to complete one revolution, and we now have 4 pi over 2 or 2 pi. 4 divided 2 is 2. It is this value. We can use this idea to determine the value of an angle which is a multiple of pi over 2. Examples. Find the values of the following. Letter A. What is sine 5 pi over 2? On the unit circle, we cannot immediately identify or spot 5 pi over 2. However, Since this is a multiple of pi over 2, we just need to count 5 times in a counterclockwise direction since this is positive. Recall that this portion is equal to 1 pi over 2, then 2 pi over 2, 3 pi over 2, 4 pi over 2, and finally 5 pi over 2. It coincides with pi over 2 with coordinates 0, 1. So they have the same coordinates 0, 1 where x is 0 and y is 1. Thus, sine 5 pi over 2 is equal to 1, the y coordinate. Again, since this is multiple of pi over 2, we just count 5 times starting at pi over 2 in a counterclockwise direction since it is positive. So we count 1, 2, 3, 4, and 5. Letter B, find cosine negative 3 pi. In this case, this is a multiple of pi. Recall, this is our pi. It is equivalent sa dalawang pi over 2. However, since the given angle is negative, the direction is clockwise. How many pi's? We have 3. But take note, it is negative. So we must count pi 3 times in a clockwise direction. So we have negative 1 pi, negative 2 pi, and negative 3 pi. It coincides with this point with coordinates negative 1, 0. Thus, cosine negative 3 pi is equal to negative 1, the x value. Another example. Find cosecant negative 9 pi over 2. This is multiple of pi over 2, and we're gonna count 9 times in a clockwise direction since it is negative. So we have negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2, negative 6 pi over 2, negative 7 pi over 2, negative 8 pi over 2, and negative 9 pi over 2. It coincides with 3 pi over 2 with point 0, negative 1. Hence, cosecant negative 9 pi over 2 is equal to negative 1. 1 over y, where y is equal to negative 1, so 1 divided negative 1 is negative 1. How about secant 6 pi? This is multiple of pi. Since the given theta is positive, we're gonna count pi 6 times counterclockwise. Thus, we have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and finally 6 pi. It coincides with this point with coordinates 1, 0. Hence, secant 6 pi is equal to 1. 1 over x, x is equal to 1, and 1 divided 1 is 1. So that is how you determine the value of a function that is a multiple of either pi or pi over 2. Aside with these quadrantal angles, we also have 3 special real numbers, pi over 6, pi over 3, and pi over 4, which are equal to 30 degrees, 45 degrees, and 60 degrees respectively. First, let's deal with pi over 6 and its multiples. Pi over 6 is equivalent to 30 degrees. In the unit circle, this is 30 degrees or pi over 6. Now, what are the coordinates of pi over 6? If we're going to draw a line from this point downward, we have created a right triangle. Recall that the sum of a triangle is 180 degrees. So if this angle measures 30 degrees, while this is 90 degrees, this angle measures 60 degrees, a total of 180 degrees. This side is x, it is on the x-axis, while this side is y, this is parallel to the y-axis. To determine the value of x and y, we need to remember from our geometry the concept about 30 by 60 by 90 degree right triangle. It says that in a 30 by 60 by 90 degree right triangle, the side opposite the 30 degree angle is always 1/2 the length of the hypotenuse. The opposite side of 30 degree angle is y, and the value of this is 1/2 the length of hypotenuse. So we need to determine the length of this side, the hypotenuse. Recall that a unit circle is a circle whose center is at the origin and with a radius of 1 unit. So this is equal to 1. Thus, the value of y is 1/2. half the length of hypotenuse. Half of 1 is 1/2. Next, we determine the value of x. To determine the value of x, we use the equation of the unit circle, which is x squared plus y squared equals 1. Since y is equal to 1/2, we have x squared plus 1/2 squared equals 1. Simplify 1/2 squared, and that is 1/4. 1 squared is 1, 2 squared is 4. Transpose 1/4 to the right side, then simplify. 1 minus 1/4 is 3/4. 4 times 1 is 4, minus 1 is 3. Extract the root, we have square root of 3 over 2. Square root of 3 is square root of 3, while square root of 4 is 2. Thus, the coordinates of pi over 6 are square root of 3 over 2, 1/2. Next, we determine its multiples. First, we need to determine how many pi over 6 are there in the unit circle. So we divide 360 by 30, and that is equal to 12. Tiga-anim sa taas at baba. Here, we already have 1 pi over 6. Remember, we need to divide the circle by 30 degrees to 12 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now that we have divided the circle into 12 parts, measuring 30 degrees each, we can now identify its multiples. The multiples of pi over 6 are determined by this auxiliary rectangle. So these points are the multiples of pi over 6. These multiples have the same coordinates with pi over 6 that only differ in sign. But before that, we need to identify what these points are. The reason why we divided the circle into 12 parts kasi ito ang magdidetermine kung ano-ano ang mga points na ito. If this is 1 pi over 6, this point is 2 pi over 6, or 1 pi over 3, in lowest form. Next, this point is 3 pi over 6, or pi over 2 in lowest term, which is correct. This point must always be pi over 2. After this, we have 4 pi over 6, or 2 pi over 3. Thus, this point is 5 pi over 6. After this, we have 6 pi over 6, or pi, which is truly the value of this point. Then this point is 7 pi over 6. Followed by 8 pi over 6, or 4 pi over 3. Then 9 pi over 6, or 3 pi over 2 in lowest form, which is also the correct value of this point. Next, we have 10 pi over 6, or 5 pi over 3. Then this point is 11 pi over 6. And finally, this point is 12 pi over 6, or 2 pi. So the points 5 pi over 6, 7 pi over 6, and 11 pi over 6 are the multiples of pi over 6. Which means, kung ano ang coordinates ng pi over 6, ay ganun din ang coordinates ng kanyang multiples. Nag-iiba-iba lamang sa sign depende kung nasa anong quadrant ito. Since point 5 pi over 6 is located on quadrant 2, the sign of x coordinate is negative, while y is positive. On the other hand, since 7 pi over 6 is located on the third quadrant, the sign of x and y are both negative. While 11 pi over 6 is on the fourth quadrant, thus x is positive while y is negative. And these are the multiples of special real number pi over 6. We use this concept to determine the values of circular functions that are multiples of pi over 6. Examples. Recall that these are the 6 circular functions, and let us find the values of the following. These are multiples of pi over 6. Just remember that if the given value is positive, we count in a counterclockwise direction, while clockwise if the given value is negative. Letter A, find sine 5 pi over 6. And we can determine this value right here. Since we're looking for the value of sine, which is equal to y, the answer is 1/2, the y coordinate of this point. Letter B, what is cosine negative 7 pi over 6? On the unit circle, we cannot immediately see negative 7 pi over 6 since this one is positive. But since this is multiple of pi over 6, we count 7 times in a clockwise direction. We start in here. This is negative pi over 6, then negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 pi over 6, and negative 7 pi over 6. It coincides with this point with coordinates negative square root of 3 over 2 and 1/2. Thus, cosine negative 7 pi over 6 is negative square root of 3 over 2, the x value. Next, find tangent 11 pi over 6, and it is this point. Tangent is equal to y over x, where y is negative 1/2, while x is square root of 3 over 2. This is equal to negative 1/2 times the reciprocal of the denominator, which is 2 over square root of 3. Negative 1 times 2 is negative 2, while 2 times square root of 3 is 2 square root of 3. Cancel out 2, we get negative 1 over square root of 3. Rationalize the denominator by multiplying the numerator and denominator by square root of 3. So negative 1 times square root of 3 is negative square root of 3. And square root of 3 times square root of 3 is 3. Square root of 9 is 3. Thus, tangent 11 pi over 6 is equal to negative square root of 3 over 3. Letter D. Find cosine 210 degrees. First, convert 210 degrees to radian measure, and that is equal to 7 pi over 6. 210 times pi over 180 is equal to 210 pi over 180 degrees, or 7 pi over 6 in lowest term. 7 pi over 6 is located here, therefore cosine 210 is equal to negative square root of 3 over 2, the x coordinate.